Can you both shift this side? Those are online. Are you able to hear me?
Yes, sir.
Shall we get started?
Yes, sir.
Yeah. So previous class, what were we discussing? We saw the first concept, right? Which was about converting the angle from one measure to another, from the angle, from the degree measure to radian measure and the vice versa, right? I hope everyone is clear, no? So you know how to do it.
Yeah,
Okay.
sir.
Yes. Now, the next question that we need to answer is, till last year, like till your 10th grade, I think you learned last year only for the first time. No? Okay. In your 10th grade, you learned the values of different trigonometric ratios from 0 to 90 degrees, right? So when I say 0 to 90, right, if I imagine a line being rotated in the anti-clockwise direction starting from positive x-axis, so what is the angle you are covering? 0 to 90. When you do 0 to 90, in which quadrant you are constraining yourself? Constrained to first quadrant. But it is not necessary that all the angles that we are going to measure are going to be only between 0 to 90, right? So we need to understand how to deal with them when the angle is more than 90 degree also, right? For example, if I ask you what is sine 30, you will tell me what is the answer. Sine 30 is going to be 1 by 2. If I slightly ask a question of, change the value to sine 120, so that's something which you don't know as of now, right? So what we are going to do today is understand how to calculate the trigonometric ratios for angles which are greater than 90 also. Okay. So that's what I'm going to start with. So before that, I'm going to touch upon certain concepts from your 10th grade. Not sure if you have learned it or not, but I'll explain it this. Yeah, I think you would have not learned it, but okay, yeah. So the topic is trigonometric ratios and their signs in each quadrant. So trigonometric ratios and their signs in each quadrant. Okay. If I take the basic coordinate system like this, so x dash, y dash. Okay. So if I take a point here, which I'll call it as A comma B. So where did I take that point? In the first quadrant. So if I take this point to be P, from this point, I'm going to drop a perpendicular onto the x-axis. When I do this, I get the foot of the perpendicular. You know what is the meaning of it? When you drop the perpendicular, wherever the perpendicular is intersecting the base is called as the foot of the perpendicular. So the distance from the origin to the foot of the perpendicular drop from P onto the x-axis is going to be of how much value? How much is this distance going to be? Obviously, A. Similarly, from here, if I drop a perpendicular onto the y-axis, this distance is going to be B, right? If this is B, this is also going to be B. If I take this to be M, for instance, MP is also B. If I take this to be O, and if I take this to be N, ON is also B because it forms a rectangle, right? But since I'm concerned with respect to trigonometry, I'm not interested in a rectangle. I'm interested in a right angle triangle. So what I'm going to do is I'll construct from O to P. If I join it, if this distance is A and this is B, then how much is OP going to be? Root of A square plus B square. Now my discussion is confined only to the first quadrant. So if I take the quadrant 1, and if I take this to be theta, right? So what is sine theta? Opposite by hypotenuse. So directly I'll write it B divided by square root of A square plus B square. What about cos theta? A by root of A square plus B square. What is tan theta? It is going to be B divided by A. What about cosecant theta? It is going to be root of A square plus B square by B. What about secant theta? A square plus B square, the whole divided by A. What about cot theta? Sorry, A by B. If you observe in the first quadrant, the abscissa and the ordinate both take the positive sign. That is, the x coordinate and the y coordinate both take positive sign. So when I write any trigonometric ratio, if you observe, root of A square plus B square is positive, right? But when I write the sine theta, cos theta, everything, I have an individual variable existing. So here B is positive, A is also positive. So here positive by positive is going to be positive. So if the first three are going to be positive, the remaining three will also be positive. The meaning of it is, whenever you take an angle and write the trigonometric ratio, which is confined to the first quadrant, all the trigonometric ratios will give you a positive value. That is why in the first quadrant, it is said that all trigonometric ratios are positive. So when I say first quadrant, I understood that the angle is going to be between 0 to 90 degrees. Though 90 is going to be belonging to the first and the second quadrant, okay, we'll take it as 0 to 90. Am I clear with this? No. First listen, then I'll give you time to write. Okay. Now, if I bring the discussion to the second quadrant, I took the point P there, no? I'll take a point P dash, which is at the distance A and B only, but this time it is going to be minus A comma B. Am I clear with what I'm saying? So from here, if I drop a perpendicular, the foot of the perpendicular, let me call it as M dash. Okay. So from here, I'll call it this as N dash. So how much is the distance from the origin to N dash? The distance is B. What is the distance from the origin to M dash? Distance is still A. Distance is still A. Right. So if I join these two, then what am I going to get? OP is equal to root of A square plus B square. Again, what I'm going to do is, if I do an analysis, then in quadrant 2, I'm going to get sine theta as B divided by square root of A square plus B square. What about cos theta, I'll get a divided by root of a square plus b square. What about tan theta? I'll get it as b by a. So I'll take only these three ratios and do the analysis. If you observe b is getting along the positive y direction. So this value is positive and this value is positive. So positive by positive is going to be positive. So here I'm going to write only those trigonometric ratios which are positive. So which one is positive? Sin theta is positive. So logically, if sin theta is positive, cosecant theta by default will be positive. So root of a square plus b square divided by b. So I understood that sin theta in this quadrant is a positive value and cosecant theta is also going to be positive. Then what about cos? For cos, a is negative, whereas this is positive. So if cos is positive, negative, so negative by positive is a negative one. If cos is negative, then secant theta, which is root of a square plus b square divided by a, is also going to be negative. So that will not come in that scenario. So if sine is positive and cos is negative, we know that tan theta is sine by cos. So positive by negative is again going to be negative. If this is negative, then cot theta, which is equal to cot theta, which is equal to a by b, is also going to be negative. So the meaning of it is, whenever you're writing the trigonometric ratio of angles which are confined to the second quadrant, when I say angles confined to second quadrant, what am I saying? The angle is somewhere between 90 to 180 degrees. Meaning, if I ask you what is sine 120, cos 120, something like that, you should understand that I'm talking about second quadrant because they fall in this range. See, here I'm talking in terms of degrees still. But slowly your knowledge should get expanded to radian because they'll give you in radian only. All the values will be given in radian, but don't worry, you'll get it with practice. Okay. So 90 to 180. Listen, when I talk about second quadrant, which two trigonometric ratios will give me positive value? It is only sine and cosecant. Everything else will give me a negative value. Okay. So there is a pattern which will be followed everywhere. So using the same logic, okay, using the same logic, I'm not going to write everything again. If I extend this concept to quadrant 3, so if I extend it to the third quadrant, then what am I going to get? I'll take a point here, which is a comma b only. Okay, I'll write it in the next. So if I bring this discussion to quadrant number 3, then I'll take this point as p double dash, which is minus a comma minus b. A and b both are negative. If I drop the perpendicular again, then what will I get? If I take this to be m double dash, if I take this to be n double dash, this distance is how much? Distance is b and this distance is a. So from O to P double dash, if I join, then if I take this angle, okay, listen, I just want to mention one more thing. So here I took this to be theta. Okay. So I took this to be theta. So when I take the angle in this way, it is going to be, I'm sorry, my mistake. I didn't write the angle here. This is not theta. Because I told you what is the angle? The angle should be obtuse. So where is that angle measured from? The angle is measured in the anti-clockwise direction. This value. So sine of this angle is positive, whereas cos of this angle is negative. Meaning sine of an obtuse angle is positive, cos of an obtuse angle, and tan of an obtuse angle are negative. Are you able to get some perspective out of this?
Sorry, excuse me, sir, but are you pointing at anything because I can't see?
I didn't point at anything. I wrote it here. No, I turned one angle here.
Oh, okay, sir.
Oh, video is off. Yeah, this angle.
Yeah, got it.
Yeah. Tell me. I'll connect it. That's what I'm saying. So this theta is there. No, then we'll start writing this as 180 minus theta. So I should actually connect and write it. That's why I actually missed that point. But see, but did you get a perspective that sine and cosecant, why they are negative? Okay, first follow that. Now I'll tell you how to write the sine 180 minus theta in terms of sine. Okay. First copy this. You need the previous slide also, no?
Excuse me, sir.
Hmm.
Sir, in the case of the third quadrant, everything will be positive rate, sir.
No. Check and see. Can you guys guess what will be positive? I'll give you a hint. Everything will be positive only in one pair. For example, in the second quadrant, sine and cosecant, no. Third quadrant, tan and cot will be positive. Why tan and cot will be positive? Because tan theta is b by a. B and a both are negative. Balaji, are you able to understand?
Yes, sir.
Yeah. Similarly, in fourth quadrant, even without doing, can you guys guess it? What is left out? Cos and secant. Okay. Did you all finish? Okay. So I want to stress on one important point here. So let's come to the third quadrant later. So if I see the first quadrant, right, this is theta. If I drop a perpendicular from here, this is A, this is B. Am I right? So this is going to be root of A square plus B square. Now, if this is 90, this is theta, then how much will this angle be? 90 minus theta. It's going to be 90 minus theta. So if I write sine theta from this, what did I get? I got A by root of A square plus B square. Right? Sorry, B by b by root of a square plus b square. Whereas if I write cos of 90 minus theta, what will I get? Cos of this angle is there, no, 90 minus theta. So what does cos mean? Cos is adjacent by hypotenuse. For 90 minus theta, who is the adjacent side? B. So it is going to be b divided by hypotenuse is still root of a square plus b square. So are you able to relate these two? So sin theta is going to be equal to cos of 90 minus theta. It's very simple. Like if you observe, how much is sin 30 degrees? 1 by 2. What is cos 60? 60 is basically 90 minus 30, or this can also be written as cos 60, which is also a half. That is why the values will match. I don't think this was deleted, no, last year. You didn't learn this. It was there, okay. Complementary angles were there, okay. But what did they delete? But you learned it. Okay. You guys learned? Okay. So this is actually deleted last year. But this is the reason, it's very simple. Are you able to understand? So similarly, if I take cos theta is going to be a by root of a square plus b square. What about sine of 90 minus theta? For 90 minus theta, what is the opposite? A. So that's why they both will be same. So using the same logic, tan theta will be equal to cot of 90 minus theta, and cot theta will be equal to tan of, similarly, secant theta will be equal to cosecant of 90 minus theta, whereas cosecant theta will be equal to secant of 90 minus theta. So they both are complementary of each other. That's why if you see sine, cosine, complementary. Secant, cosecant, right? Tan, cotan, are complementary of each other. Correct? It goes like that. Make a note of this. Can I proceed? Okay. So listen, when I talk about the second quadrant, so when I talk about the second quadrant, right, there is a line like this, O P dash, drop a perpendicular from here. This is M dash, you drop a perpendicular from here, this is N dash, right? So always remember, generally when you take that angle is positive means it is always measured in the anti-clockwise direction. So this line was initially here. This OP dash was initially here. So then it took an anti-clockwise turn to come here, and it took an anti-clockwise turn of how much value? Theta. So for me to land on this line P dash in the anti-clockwise direction, I need to rotate through an angle theta, or I could have rotated through an angle of 180 minus theta in the clockwise direction. Right? Both are going to be land at the same place. Right? So if I take this distance to be A and this distance to be B. Right? So if I ask you what is sine of 180 minus theta from this triangle? So no, sine of 180 minus theta. This is 180 minus theta. It is B by right. It is going to be B by root of A square plus B square. Right. So if I take this 180 minus theta to be some alpha, can I call this as some sine alpha? So what is going to be the relation between alpha and theta? Alpha plus theta is going to give me 180 degrees. Is this point registered? Okay. Suppose I say alpha is equal to 60 degrees. Okay, this is an example. Suppose I say alpha is equal to 60, then what is sine of 60 degrees from the right angle? It is root 3 divided by 2. This is a known value. But what is alpha according to our consideration? 180 minus theta. Oh. So this should be sine of, tell me. So alpha is basically, how did you arrive at this? 60. Can I write it as 180 minus 120? So this is 60. 180 minus 120 is going to give me this angle. Meaning this theta, if I take it to be 120 degrees, means if I make an anti-clockwise rotation of 120 degrees, it is going to give me the exact value as that of sine 60. Am I clear with what I'm saying? Are you able to understand? So here, there are two types of pairs that we are going to consider. One is complementary pair and the second is supplementary pair. So in the previous case that we considered is something within the triangle itself. It was a complementary pair. So whenever you find the trigonometric ratios of complementary angles, you will always get the complementary trigonometric variables of. For example, sine of 90 minus theta, you got cos. Cos of 90 minus theta, you will get sine. Whereas when you do supplementary, you will get the same value itself. Same value, you will get the same trigonometric ratios. Whether it is positive or negative, it is decided by the quadrant. Meaning, sine 60 is going to be the same as sine of 120 degrees. Why 120? Because this is telling. So theta value. So when I rotate through an angle of 120 degrees in anti-clockwise direction, which is going to be this thing, theta, it is landing at the same value of sine 60 when I rotate in the clockwise direction. So that is why sine 60 and sine 120 are going to be the same values. And whether that is positive or negative is decided by the quadrant. I wrote it as root 3 by 2 here because I know in the second quadrant, sine and cosecant are positive. Whereas, if I have to write the value of cos 60, which is going to be half, this would have been, so how much should I rotate? Cos of, so I would have rotated 180 minus 120, no. So this is going to be half. So if I need cos 120, that would have been the value, the magnitude will be half only, but it will have a minus sign. So whenever I am asked this angle, all that I need to do is find the complementary of it and then do it. So to put it simple, right, I'll give you a table of how to remember these values. So remember. So if it is sine of 180 minus theta, where theta is considered to be acute. Okay, if theta is considered to be acute, then this will be equal to sine theta itself. Same is the case with cosecant. So cosecant of 180 minus theta will be the same as cosecant theta. These two are the only ones which are positive. Okay. Similarly, if I want tan of 180 minus theta, this will be tan theta only, but with a minus sign. Why minus? Because 180 minus theta falls in the second quadrant. So in second quadrant, what is tan? Minus. So similarly, cot of 180 minus theta will be. So here you're able to observe that the trigonometric ratio remains the same because it is supplementary. So it can either be supplementary or multiples of supplementary. For example, 180 minus theta, 360 minus theta, 540 minus theta, everything is a exact multiple of 180. So in that scenario, the trigonometric ratio will be the same. When will it change to the complementary one? When it is 90 minus theta, 270 minus theta, then 90 into, okay, 90 into 3 is 270, 90 into 5, 450 minus theta. So when it is an odd multiple of 90, whenever it is an odd multiple of 90 minus theta, it will always get complementary values. Okay. So don't worry, you will be able to understand when we solve problems. So what is the last one? Cos is over, no? So secant of 180 minus theta is minus secant theta. Then what else do we have? So cos I didn't write. Cos of 180 minus theta is minus cos theta. Did you understand? So make a note of this table. We'll do some problems based on second quadrant. Yeah. This table is only for second. So previous table is there, no? This one, sine and cos. This table is for first one. Okay. This is over. Okay, write it. Shall I proceed? So listen. Let us take some angles in the second quadrant. Suppose I want to find the value of sine 135 degree. What am I supposed to do? Sine 135 is the same as sine of 180 minus 135. How much is this going to be? So answer will be 1 by root. Similarly, if I want to find cos of, let's say 120, I think cos 120 already found. So how much is it going to be? Cos of 180 minus 60. Answer will be, sorry, 180 minus 60. Then, what did I write there? Cos theta is cos. Cos 120, when how will you write it? You'll write it as 180 minus 60 only. No? Here I wrote it wrong. Cos of 180 minus 45, because what did I tell you? When you write cos of 180 minus something, you need to ensure that the value of theta is acute. So here, cos 135, which is an obtuse angle, how much should I subtract from 180 to get this cos 130 to get 145, which is an obtuse angle? So that value is what you're supposed to write. So it's 1 by root 2. So cos 120 is cos of 180 minus 60, which is going to be minus cos 60. Tell me some other number. 129. But no value theriyadhu. So I'll tell you what is cos 129 degrees. So it will be cos of 180 minus 51. So answer will be minus cos 51 degrees. You don't know the value, but yeah, this is going to be the answer. So here it will be minus half. So you're able to understand? So except for sine and cosecant, everything else will be negative. Shall I proceed? Those who are online are able to understand?
Yes, sir.
So now if you take for quadrant 3, right, when you take the third quadrant, right? So if it is going to be like this, if I take this to be the value of theta, then how much will this angle be? It is going to be 270 minus theta, right? So whether you rotate through a reflex angle, what is this angle going to be? Not call it, yeah. So if you're going to rotate at an angle greater than 180 degree and less than 270 degree, you're going to land in the third quadrant. Okay. So when you're landing in the third quadrant, when you rotate through this much angle, theta angle in the anti-clockwise direction or 270 minus theta in the clockwise direction, it is going to land at the same point or on the same line. So if I take this to be O, if I take this to be P double dash, I'll drop a perpendicular. This is going to be M double dash and this is going to be N double dash. Okay. So how much is this going to be? This point, if I take it as minus A comma minus B, this distance is A, this distance is B. Right. So when you land in third quadrant, the first thing that you need to keep in your mind is tan and cot are positive. So they are going to be positive, except that everything else is going to be negative. Okay. So whenever you write sine of 270 minus theta. Right, when you write sine of 270 minus theta, what do you think you are going to get? So if you observe, 270 is 3 times 90. So it is again going to be a complementary value. Any odd multiple of complementary is of 90 is going to be complementary. It is going to be cos theta, but the only thing is it's negative. By third quadrant, only tan and cot are positive. So similarly, cos of 270 minus theta is going to be equal to, that's it. So having said this, suppose I want to find sine of 225 degrees. Sine of 225 is what I want to find. So can I write this as sine of 270 minus 225? Sorry, sine of 270 minus 45. So sine of 270 minus 45 is 225. Okay, this will be minus cos 45. So answer will be, so sine 225 is equal to negative of 1 by root. Am I clear with this? Similarly, you want cos 225, it will be minus sine 45. So now you tell me, tan of 270 minus theta, how much will it be? Minus cot theta. Sorry, plus. So cot of 270 minus theta is going to be tan theta. Similarly, you write down for the other two. Okay, make a note of it. So let me know once you're done. So what about the fourth quadrant? So quadrant 4, which functions are going to, cos theta and secant theta are going to be positive, right? Right. So when I want sine of 360 minus theta, what will I get? How did you say sine theta? Because 360, see, whenever you need to say something is complementary, it should only be an odd multiple of 90. It should not be an even multiple of 90. It is 4 into 90. Yeah, negative sine theta. So similarly, cos of 360 minus theta. Cosecant of 360 minus theta minus cosecant theta. Like this, you can write for the other trigonometric functions. So what will you get? Tan of 360 minus theta is minus tan theta. Cot of 360 minus theta is secant of 360 minus theta is equal to secant theta. Okay. So now we are ready to do the problems. Okay, open your textbook. Go to the exercise. Yes. So look at example number 6. You just read the question, I'll do it. What is the page number? 55. So page 55, look at example number 6. Ada. Okay, read the question. Okay. X license. Okay. It's simple, no? So basically draw a right angle triangle. Take this to be theta. Okay, take this to be x. So what is cos? Adjacent by hypotenuse. So don't just write it as 3, write it as 3k. This is 3k, that is 5k. Then how much will this be? This will be 4k, 3, 4, 5 or Pythagorean triplets. So what is sin x? So what are the other trigonometric ratio that we need? Sin, tan, cosecant, secant. Okay. What is sin x? 4k by 3k, which is 4 by 3, but with a minus sign. Third quadrant. Oh, sorry, 4 by 5. Third quadrant. So it is minus. Tan x is, yeah, you write those steps. Minus 4 by 3. What is cosecant x? The reciprocal of it. Minus 5 by 4. What is secant x? Minus. Oh, tan is positive, no? Cot is 3 by 4 because third quadrant tan and cot are positive. Did you understand this? This is something you would have done last year, no? Writing the trigonometric ratios. But the only expectation is you need to put plus or minus sign. Should I proceed? Next question. What is the next one? Example 7. What is example 7? Similar question. No? Then you people do it. Okay, do it fast. Cot x is equal to minus 5 by 12. So cot x is equal to minus 5 by 12. Which quadrant? Second. Find the other trigonometric ratios. So what are the Pythagorean triplets? 5, 12 and 13. Got it? Proceed to the next one. So what is the next question? 31 pi by 3. Yeah. So I want you all to concentrate. The value they are asking is sine of 31 pi by 3. Okay. See, since we dealt with degrees, first let's try to understand what they are asking. So 31 pi by 3, you will multiply it with 180 by pi. Cancel this and this, it is going to go 60 times. 60 into 31 is going to be 1860. So 1860, you need to find sine of this 1860. I don't know how many rotations it is going to make. So it's simple. See, just to give you a perspective of what it means, 360 is 1. Like this, if you divide with 360, how many such rotations will you get? Okay, 7 point something. I'm not concerned about the number. 7 point something now. It has completed 7 full rotations. After that, it has landed somewhere. We don't know which quadrant it has landed. Unless we divide it properly, we will not be able to see. Okay. So we are not going to think in these terms. All that we have to do is simplify this and write it in the form that we need. So we wrote the table, right? I wrote sine of 180 minus theta. No. What is it? Sine theta. So instead of 180, if I replace it with pi, sine of pi minus theta will also be sine theta, because we know that 180 degrees is pi radian. Since here pi is involved, all that we need to do is bring it to this kind of a form. Okay, for that, if you have these kind of problems, always look at the ratio. So there are two possibilities where the numerator can be greater than the denominator, or numerator can be less than the denominator. In this case, what is happening? Numerator is greater than the denominator. So what I will do is I will write sine of this 31. If I divide it with 3, what will be the remainder? It is going to be 1. So basically, can I write this as 30 pi plus pi the whole divided by 3? Right. So can I write this as sine of 30 by 3 is going to be 10 pi plus pi by 3. Am I clear till this point? Yes. Okay. So sine of, observe, this 10 pi, I will write it as 2 into 5 pi. Sorry, I'll write it as 5 into 2 pi. What is the meaning of this? 2 pi is 360 degrees. So it has completed 5 full rotations to get this 10 pi plus a pi by 3. Pi by 3 is how much? It will take some time to process. It is 60 degrees. Pi by 3 is 60 degrees. So after completing 5 rotations, where have you landed? In the first quadrant. So sine of 10 pi plus pi by 3 is pi by 3, 60 degrees into 180 by pi. Other 10 pi, I wrote it as 5 into 2 pi. Uh-huh. 10 pi, I wrote it as 5 into 2 pi. 2 pi is it is one full rotation, no? Like that, how many such rotations have been completed? 180 is pi. So don't take 10 pi. So 10 pi means 5 full rotations. So after that, where are you landing? You're landing at pi by 3. So sine of 5 full rotations plus, I told you one thing, remember, whenever it is an even multiple of 180, you should write the same trigonometric ratio. So it will be sine of, what is this angle? So what is sine pi by 3? Is root 3 by 2. Okay. This one, you will get it by practice. But the first point that I want you to understand is this thing, how to break it into different values. So what did I say? Whenever you look at the ratio, look at the numerator and denominator. When the numerator is greater than the denominator, try to write it as something plus something. Some scenarios, you will get the numerator less than the denominator. At that time, you will write something minus something. For example, I'll explain that also, then you can copy. If I have to find the value of sine 3 pi by 4, numerator is less than the denominator. So sine of, what should I do to this 3 to bring it close to 4? I can write it as 4 pi minus pi, the whole divided by 3. Sorry, by 4. So I'll get sine of pi. So sine of 180 minus pi is 180. Pi is 180. Pi by 2 is 90. So sine of pi minus pi by 4. Pi by 4 is 45 degrees. So which quadrant is it? So this will be sine pi by 4. It is second quadrant. 180 minus theta. 180 minus theta is second quadrant. So sine pi by 4 is going to be 1 divided by root. Did you understand? Did you understand how to, like, you know, when will you get minus and when you will get a plus sign? Depends on whether the numerator is greater than or less than the denominator. Clear with this? So this is actually a famous value. Sine 3 pi by 4 is basically 135 degrees. Pi by 4 is 45. 45 into 3 is 135. We derived it, no? Sine 135. You look at your book. Did I write sine 135, cos 135? Something I would have written. I wrote it, no, 1 by root 2. That's why that value. Only thing is, instead of degrees, I wrote it in radian. Okay. Don't worry, you will get it. There's just second class. Okay. You will get it with practice. Don't worry about it. It's not 3 pi by 3, 3 pi by 4. Oh. No. Sorry, sir. This is right. Oh, I thought you wrote the second. Okay. Sine 31 pi by 3. Should I proceed? What is the next question? Cos of minus 1710. 1710. So first thing I would like to tell you is, if this is there, if I take this angle to be theta, how am I measuring that angle? Clockwise, no? So if something is measured in the anti-clockwise direction, you take it to be positive, whereas clockwise is considered to be negative. So when I take cos of an angle in the negative direction, then that will give me cos theta itself. Reason being, it falls in the fourth quadrant. So cos of minus theta is equal to cos theta, because you see everything that I've written is terms of acute angles. So what I'm trying to say is cos of minus 1710 is going to be cos of 1710. Both have the same value. So all that you need to do is divide this 1710 with 360 and tell me what is the remainder you are getting. I'm concerned about the remainder, not the quotient. So 171 divided by 36. How much are you getting? 27. So what is the quotient? 144. You got 27. So 270. So you have a 0 here, you have a 0 here, you'll get a 0, you'll get 270. Correct? So can I write this as cos of 4 into 360 plus 270? Right. So cos of 4 into 360 means, where am I going? 4 times I have completed full rotations plus 270. So at the end of fourth rotation, I'm here. Then 270, I'm coming and landing here. So exactly in the third quadrant. So this value, what can I write it as? Okay. See, one thing I want is, I'll tell you another logic. Whenever you're writing this 4 into 360 plus something, right? Ensure that this angle is acute. Always ensure that the angle is acute so that you can make better decisions. So can I write it as cos of 4 into 360 plus? This can I write it as 360 minus 90? Am I clear? So this will be cos of 4 into 360 plus 360 is 5 into 360 minus 90. So 5 into 360 is 5 into 360 means I completed 5 full rotations. Minus 90 means, so I have come back in this direction. So fourth quadrant. So this value will be cos of 90 itself. But what is cos of 90? That's the answer. Okay. Book that. So they wrote it as 1800 minus the same logic. See, guys, I will tell you one more thing. Listen to this very carefully. Like how I told about the numerator and denominator. Whenever you are trying to write the angle, you are writing 4 into 360 or 4 into 270 something, no? After that, whether you have a plus or a minus, after the plus or the minus sign, always ensure that the angle that you're writing is acute. So I just want one thing to be confirmed. Do you know when to convert it to cos and when to write it as cos itself and when to write it as sine? In this question, did you understand why I wrote it as cos 90 and not as sine 90? Why? It's not about fourth quadrant. It's an even multiple of 180. So 360 is there. You'll write it as 2 into 180. So 5 into 2, 10. 10 times 180. 10 is an even number. So even number times 180 is going to give you the same value. If it is cos, it will give you the same cos. Only thing is, you should decide which quadrant it is and add the plus or the minus. For example, had the same question been sine of minus 1710 minus sine 1710. So you will do everything with respect to 1710. You landed at this step. So what will you write at the end? You will not write minus cos 90. You will write minus sine 90. You sine the Sonia. Sorry, you will write minus sine 20. So answer will be minus 1. Are you able to understand? So that's what you need to do. Shall we do some problems? You will get it, don't worry. Yeah. So exercise 3.2. Tell me the first question. And the quadrant, those things don't tell me. You people do it, that you know. Oh, this one. Okay. Yeah. So second question, find the values of trigonometric ratios where the angles are sine 765 degrees. So 765 with what will you divide? Always divide with 360. So what is 3? This is a simple number. 360 into 2 is 720. So basically it is 720 plus 45. So this will be sine of 720 plus 45. But 720, is it an even multiple of 180 or even multiple of 180? So what should happen? The function should remain it will be sine only. Sine 720 meaning it has completed 2 full rotations. So after 2 full rotations, plus means you are landing in the first quadrant. Minus means you are landing in the fourth quadrant. So first quadrant, what will happen to sine? It is positive. So sine of how much? This acute angle. So what is the answer? The answer. That is all you need to do. Those who are online are able to understand.
Yes, sir.
Yes, sir.
Yes. So are you able to visualize in terms of rotations? Yes. Next one. Cosecant of minus. Okay. So what it? Degree. Yeah. Minus cosecant 1410. So how many times are you making? So divide with 360. What is the answer you are getting? The remainder or the? What is the remainder? So basically, see, logically what you can do is you're getting an a reflex angle over the pair greater than, you're getting the remainder as 330 rho. So you always have to look at this. Some multiple 30s you can remember 360, 720, after that 1440. So 1410 is closer to 1440. So what you can do is you can write this as 1440 minus 30. Make sense? So 1440 minus 30. So 1440 is an even multiple of 180. So whenever you have even multiple, what will you write? Cosecant either, sorry. So minus, so 1440 minus 30. Which quadrant are you landing? Fourth quadrant. So in fourth quadrant, cosecant is negative. So minus of minus cosecant 30. What will the answer be? Hold on. Half 2. So that should be the answer. Akhil, are you able to understand? Rohit, clear? So listen, what is the next question? Tan of what is the logic we need to use? Look at the numerator and denominator. Greater than? Yes. So 19, what multiple of 3 will be closer to 19? 18. So you will have tan of 18 pi plus pi, the whole divided by 3. So you will have tan of 6 pi plus pi by 3. 6 pi means how many rotations are over? So write down the values. Yeah, complete. What is the answer? So basically, so which quadrant are you landing in? First quadrant. So it will be tan of pi by 3 itself. Answer will be root 3. Clear? Next one. So you have the questions in this 3.2 exercise. You can go. Sine of wait, I'll take a fresh page. 4. What are the questions? Sine of sine of minus theta. Minus sine theta. Minus sine of 11 pi by 3. Numerator is greater than the denominator. So closest multiple is 12. So you have 12 pi minus pi, the whole divided by 3. So minus sine of 4 pi minus pi by 3. So sine of 4 pi means 2 rotations. Minus pi by 3 is fourth quadrant. So minus is there. Since you are coming into fourth quadrant, sine will become minus sine. Minus sine of how much? This angle. So sine of answer. You proceed, don't wait for them. What is the next question? cot of minus 15 pi by 3. Nearest multiple. So minus cot of 15 pi by 4 minus cot of 4 pi minus pi by 3, pi by 4. Am I right? This is what you will get. Because you'll write this as 16 pi minus pi. So 16 by 4 is 4 pi minus pi by 4. Minus outside, which quadrant? Fourth, minus, sir. Fourth. So minus cot pi by 4. So answer, minus of minus plus. So cot pi by 4, answer is 1. Cot pi by 4 is 45 degrees. That thing alone you need to get used to, no? By next week, make sure that you remember all the degrees to radian, at least the famous ones. Next. It was about to fall. Yes. That's it. Huh? The next exercise, you can see that you will have something based on ratios, the identities, right? I'll just give you the outline of what those problems are. So tell me what is the first question? Is equal to minus 1 by. This is what we need to prove, no? See, basically logic is sine square 30. Sine square 30 is 1 by 4 plus cos square 60 is also 1 by 4 minus tan square 45 degrees, which is 1. 1 by 4 plus 1 by 4 is half and minus half. That is what we need to do. So basically they're giving practice for the radians. I told you, no, that is what we need to do. Right? Can we try 2-3 problems based on that? Yeah. See, those who are online, I hope you could understand this problem. Did you?
Yes, sir.
Yes, sir.
Yes. So tell me one more question. 2 sine square. Into cos square pi by 3, 3 by 2. That's it, no? See, simple. 2, leave it as it is. What is sine pi by 6? Pi by 6 means 30. So sine square pi by 6 is 1 by 4 plus cosecant 7 pi by 6. Let me deal it separately into cos square pi by 3, cos 60. 1 by 2. So 1 by 2, the whole square is 1 by 4. Now, this one alone, I need to simplify it. So what is cosecant? Let me call this as equation number 1. So I'll take cosecant 7 pi by 6 separately. So numerator greater than the denominator. So you'll get a plus. So what will the answer be? Cosecant of pi plus, I hope you know, I wrote it as 6 pi plus pi by 6. Pi plus pi by 6. So cosecant of pi plus pi by 6. Pi plus which quadrant you are landing in? 2 pi plus na first quadrant. Pi plus is third quadrant. In third quadrant, cosecant is minus cosecant of answer. Take it and substitute it here. So minus 2. So using 2 in 1. So when I use 2 in 1, I get half plus 4 into 1 by 4. Cancel this and this. 1 plus half is 3 by 2. That's what we have. Clear with this? Yeah, Solomon. Pi by 6, see, sine pi by 6 is half. So cosecant is 2. Yeah. Clear? That's what is second exercise all about. I hope the concept is registered. No. See, what I did is actually I didn't go in depth also of you see for the third and fourth quadrant I didn't go in depth. What I'll do is if time permits, I'll record a good video and send it to you on detailed description of how to think. I wanted to mainly I've seen many of them struggling of handling this, so I thought I'll concentrate more on problems. Okay, but I could understand that you're able to do on your own. It's a good thing. So by next week, you should be strong with this. Only thing is, at least the basic angles recollect and come. I'll just give you the table. If you need, you can make a note of it. It's very simple. The angle in terms of 0, 30, 45, then 60, 90, then maybe you can write 120, 150, and 180 also. Actually, you can write 135 also. 135, 150, 180. Okay. So what is 0? 0 only. Pi by 6. There is one more confusion that happens. I've seen many of them making this mistake. Pi by 6, now they'll write it as 60 degrees because they'll get carried by the 6 in the denominator. That's one common mistake that happens. Pi by 6 is 30, pi by 3 is 60. They are exchanged. Okay. So pi 45 degrees is pi by 4. This is pi by 3. This is pi by 2. This is basically 120 is 2 times 60. So 2 pi by 3. 135 is 3 times 45. 150 is 5 times 30. 5 pi by 6. 180 is 6 times 30, which is basically pi only. Did you understand? So these are the angles you need to remember. If possible, you yourself as an exercise, prepare from 180 to 360. Till 2 pi, you write it and see. Only then your brain will work. Okay. So do that. And next class, I'll solve the third exercise. Then we have identities. Okay. Trigonometric identities, I've already recorded a video. I'll share it with you guys. Make a note of all the proofs that I've explained. Total video put together should come somewhere around 25 minutes. Okay. I've explained it slow only, but if at all you get a doubt, at least rewind and see and come so that I can concentrate more on problems here. Okay. So next week, what we are going to do is 3.3 and 3.4. Okay. Yeah.
Thank you, sir.
Yeah, ma.
Thank you, sir.
Yeah. Yeah.